So yeah, I took Kenny's suggested title literally, looking around Antarctica, and I thought I'd give a quick sort of look back over over two decades of integrated aerogeophysical surveys, BAS, some of which I've been involved with, some of which were before my time, and some of which were during my time but I wasn't directly involved with. But I show some of those here because they were, I think, relevant to rings. So what is the BAS aerogeophysical system? It's ski-equipped twin otter with integrated geophysical payload, so we get all our different geophysical techniques at the same time. It's got a survey range of about 1,000 kilometres. This does depend a little bit on configuration, but also operation altitude. So if you're very high altitude, like the AGAP survey flights, we were routinely getting 1,100 kilometres, but down at the coast, it's more like 1,000. And if you put extra antennas on above and beyond what you can see in that picture, that'll cut down your range even further. So sometimes you have to think about that and trade that off. The current typical installation, starting with the radar, is the PASSIN 150 megahertz radar system. It's got 8 transmit elements and either 8 or 12 receive elements, which allows us to do cross-track swaths if we want to, and if we have the processing time to pull that out. We transmit 5 pulses, short pulse, 1 microsecond, and then 4 microsecond chirps, which get down for the full when we want to image the deep ice. And the phase can be reversed on some of those to help with the radar processing, and that's not my field. And we have an optional polarimetric mode with the radar system where we physically rotate half the antennas by 90 degrees. So that's something we might have, if you wanted to use that mode, you'd have to decide that before going into the field and before sort of setting up the whole system. We have currently using an IMAR strap-down gravity system. It's got a resolution of 5 to 6 kilometres with an accuracy of 1 to 2 milligals, which is pretty good. And the great thing about this new system is you can fly draped. So you can fly optimal radar elevations, optimal mag elevations, and still collect gravity, whereas in the previous configurations, you always had to compromise on one of the systems if you wanted to get good gravity, whereas this way you can get all the data streams together. We use Syntrex cesium magnetometers out on the wingtips, and a Regal scanning LiDAR for ice sheet surface elevation. This is mostly as a reference for the radar ice thickness. And then we have additional systems we can fit. We can fit the creases accumulation radar, downward-looking camera, and hyperspectral instruments. Though of those additional instruments, we can't fit them all at the same time because the camera bay has a limited area. So the more systems you try and squash into that little area, we can't get it all in. So you have to make some decisions on that. So where has BAS been over the last, well, more than 20 years? And what have we done? And as you can see, we've been an awful lot of places, and this has been possible because of international collaboration largely. But prior to 2004, we were typically doing little postage stamps, quite often either single dominant sensor in a single area. And then post-2004, we went to these big regional integrated aerogeophysical surveys. Fausto was leading quite a lot of these. And these large regional surveys were really leveraging on big international collaborative expedition to actually make them work. And these made a really significant impact in filling in the big gaps in BEDMAP and ADMAP2. But potentially these sort of really big regional surveys aren't ideal visions of rings because they're very ice sheet interior focused and filling those big gaps in the interior. And Kenya had specifically asked, can we look at what coastal surveys have you done? And you can see in those bright blue surveys along the eastern side of the Ronnie Filchner ice shelf. And I thought this Filchner ice shelf system survey from 2015-16 It's potentially quite a good rings template. Is this the type of surveys we want rings to be doing? To get really good coverage close to the grounding line. It's 2.5 kilometre line spacing, approximately orthogonal to flow. Extends 5 to 10 kilometres offshore, but basically as far as the grounded ice goes. And then 100 to 150 kilometres upstream. So are these good definitions of what we want to be doing with rings? And it gives you a really good characterisation of bed elevation close to that grounding line beneath the fastest flowing ice streams, this is really nice. But some of the smaller glaciers are missed, so we're not getting this full gateway of what is the discharge into the ocean from Antarctica. We're getting most of it, but we are missing some of it, and how important and how significant that some of it is something we need to decide within rings. But also, we're missing large areas where the bed is below sea level, and this is really going to matter if we want to predict future change, because all these areas outside that blue contour, the bed's below sea level, so it's vulnerable to warm ocean waters, and it makes a very good gateway for ice to flow into the ocean. And you can actually see that up here. One of the areas that isn't covered is this big branch of the recovery where it's flowing across a bank, and also some of the areas where it's not currently flowing fast but could flow fast in the future. So for rings, do we want to think about how we could have maybe linked up these surveys better to make a more complete grounding line coverage? So just something to think about. Is this the type of survey we want for rings? I think in some ways yes, but in some ways we could have ring-like additions to it to make it a more complete ring. Other offshore surveys, Thwaites and ITGC, we did we did a relatively small aerogeophysical campaign down there, and it was flown over 2 seasons, but it was quite a complex survey, and we had about 4 or 5 different PIs and projects feeding in, specifying the science targets, so this is why you get this quite complicated survey plan. And it was designed to interleave with the Operation Ice Bridge and Agassiz lines to extend and improve the resolution of the previous surveys. And we had collaboration with Creasis and Lamont to get additional radar and gravity systems on board the Twin Otter, which was really beneficial. And a couple of quick looks at the products. We had the new bathymetry, which is quite gratifying. You can see people using and showing that it's slightly offset. So maybe we need to go back and tweak that bathymetry. Now we've got better control beneath the ice shelf, where we didn't have control before, which is really nice. But it did confirm that the really deep channels that you can see offshore do link up to the deep cavity onshore depths of more than 800 metres, and that was the depth that people were saying that's where the warm water could be coming in at. So it's really important to know the sort of scale, magnitude and existence of these, confirm the existence of these channels. It also showed an interesting feature that the newly formed ice shelves, where things had just retreated, actually retain some memory of the underlying bathymetry. Which I think suggests that they've not actually totally, they're not in total equilibrium yet. So it's not like the ice sheet ungrounds and instantly it's floating and ignores the bed. It's that there's a time before we reach equilibrium, which is something to think about of how the ice sheet will retreat in this area. And also we've generated, this is currently bouncing in and out of review, hopefully we'll get it back in soon, a new sketch map of the subglacial geology, and this was taking the magnetic anomalies, the gravity anomalies and the airborne radar data to do a bit of textual analysis of the ice bed interface, and then we came up with this, an interpreted geological sketch map. And it's very much an interpretation, but I think it is probably as best that we can do of understanding what the geology is underneath Thwaites Glacier, at least at first pass. So, ongoing work, people are using this data to investigate the ice sheet structure, the shear margins, and the basic conditions in support of upcoming ground-based surveys. So, future platforms and plans. I think the Twin Otter is going to be part of the future. We are going to be doing more Twin Otter surveys. It's really well proven. It can operate from anywhere, and it's really ideal if you want that complete radar system. And I think that could be quite important for some of the science questions we want to answer. But also, you've got UAVs coming online, like the Prion Mark III. It's got a 10 kilo payload and a range of between 1,000 and maybe only 400 kilometres. But we need to work on that. We've got taking that down to Antarctica this season to do some Antarctic field testing, flying primary magnetic survey. So hopefully we will have but mag and ground on this platform are proven. So we know we can collect the data, it's just we haven't flown it in Antarctica yet. And then this is an exciting newly funded project led by the BAS engineering team with wind racers who are currently using a UAV to deliver the post up to the Scottish Islands. This is a platform with a 100 kilo payload and a 1,000 kilometre range, and we've got a funded field season in 23-24, and we want to put mag, grav and radar on board that to take this out down to Rotherham and Sky Blue to prove it. It doesn't have any skis yet, so we're limited to hard runways, but if this comes off, I think this could be a platform where we could go back to Wind Racer and really drive the development of the platform and get them to put skis on and get it as a really good operational Antarctic platform in the future. Where to go? I think I'm running very tight to my time, and that's a nod. So we're open to exploration across the continent, but local opportunities would probably be supported logistically out of Rotherham, and that's looking at the Ronnie Ice Shelf. And following up from what Graham was saying earlier, RV are traversing their seismic equipment from the coast down at the bottom up to be picked up at the ship at the top. While they're doing it, they'll collect data. Maybe we can put some rings type activity and wrap around that. For example, putting a UAV operating from the traverse to get a really good swath of high resolution magnetics and gravity to understand the cavity along the traverse route and link the ocean right down to the grounding line in this area. But there's a lot of other science that can come along on this traverse route, so I think this has potential to be quite a big thing in the next 4 to 5 years. I think it will take time to spin this up, but we're heading in this direction. And thank you very much.